So hi, my name's Orr, and actually I'm really glad to be here. It's my first time in London and at PyData, so it's been great weather so far, and I hear this is not common, so I'm happy to be here. My talk is really centered about A/B testing and our implementation of it. We're going to go through some things. So out of curiosity, who here is a software developer and works actively on this? Who here has ever run an A/B experiment? Who would like to run an A/B experiment? Yeah, that sounds about right. OK, so let's learn a little bit more. I come from Yelp, based in San Francisco, so all the way over here. And our mission is to connect people with great local businesses. I don't know how many of you have used it. Who here has heard of or used Yelp? OK, so good. Not too familiar. So one of the things is that we have millions of users, right? We've had 10 years full of content generated by lots of users. And that creates a lot of reviews and a lot of data for us to work with. And every time we work on new features or new components, we can start to use this data to learn from. Now, my team has added a new component. So we are the transaction platform team. And here we're looking at a normal Yelp business page. And you can see here Wing Wings, which is a local San Francisco delicacy for wings. And this is the component that we added, which is a way for users to directly order food from their local businesses. Now, this is a full-fledged of back-end services to run this entire service of being able to order food and being able to get it delivered. And you can imagine just adding this to a page isn't like everything that you need. There's a whole host of systems behind this. But what we're going to deal with is that we wanted to know how do we keep improving this experience for the user and how do we keep improving our conversion? Because in a lot of ways, button clicks on ads or on things like this will generate directly to revenue. So not only are we connecting users in a new manner, but we're also generating revenue in a new way for Yelp. So a year ago, we started looking at A/B experiments for our team. Now, we're mostly back-end engineers, so we didn't have a lot of expertise in A/B experiments. And we weren't sure, do we have enough users? Do we have enough time? What's the trade-off between running this experiment and these set of experiments that we would love to run and working on a new feature? So which would be better? Which would be worse? So we started this as a simple investigation to start with. And the main thing is that going to our project manager and asking them even for a first idea of what we could do as an A/B test is not a problem at all. In terms of people who deal with the product, they would love a lot of variations to be run. They would have a lot of ideas of what else could be changed. Right? So it's always a trade-off between experimentation, feature work, and continuously building on to improvements. So what we saw is that over the course of this simple investigation, we ran a set of 3 experiments, and we connected our users, and we improved our system, and we saw a total of 15% increase in revenue. So what we're going to talk today is about these set of cases of our 3 experiments that we ran. I'm going to dig deeper into how we run our experiments, how we phase this whole thing, and then how we saw the improvement from this. So with that, let's talk a little bit about what is an A/B experiment. So I'm sure you all understand vaguely, right? An A/B experiment is any time that you start with 2 variations, right? And you're comparing them. Now, of course, then the question is, when do you run this? Well, anytime you can phrase a question. So here we could phrase, is green going to do better than orange? Is green going to do worse than orange? That's a time you can run an A/B experiment. It's an entire process to putting a scientific method to your experimentation. So you can create a question, then you can create a way of doing this. Now, why? The more data you have, the better you can make a decision. The more you can understand the impact of any work that you do, and you can understand how that impact could affect you long term. And this is why we keep running A/B experiments, and something why we always want to keep running A/B experimentation. So with that, I want to talk about how. And this is really the meat of this talk. And we're going to go through these steps. So the first step to creating an A/B experiment is to have that question. What are you going to be testing? And from understanding that question, you're going to need to get all the necessary background data. That's anything from click-through rate to getting traffic results to being able to know how much traffic you're going to need and doing sample size calculation. Next, you're going to need to implement this and test it. Code doesn't just magically appear, right? So we have to do some work to do this. So we're going to implement our A/B experiment and create our framework. And then we're going to test to make sure that everything is working appropriately. Next, we're going to roll it out. Pretty explanatory on this, right? The main thing is that you get a good way of testing out any things in production, as well as actually ramping up to your necessary length. And then finally, you'll wait the period of time, and you'll get to analyze your results. So with that, let's dig into our first case study. Greener pastures. So we started first by generating our hypothesis, right? Now, let's look at our page, right? This is Wing-Wins again. And remember, this is our widget. So if we went to our product manager and we asked them, how do we make this better? One of the pretty standard A/B experiments is button colors, right? We looked about this before, right? The simple variation could be orange and green. But you can do a lot more things. One thing we could do is we could actually make this button bright red and just constantly flashing, right? This would get a lot of user attention, right? We're pretty sure if I put something on there that's just constantly blaring at your face, you're going to probably at least click on it or look at it. But that's probably going to be a pretty bad user experience overall, and it's probably going to negatively affect the rest of the page, which is actually something that A/B experiments would let us measure. But let's not get there too first. So the first thing is we're going to look at this. So our product manager considered this. OK, button color is a standard A/B experiment. So what color should we change this button to? Well, green, right? Green's the color of money. Green's successful. Green means go. So you're going to want to click that button now. OK, that's an understandable statement. So now we have a question. Is green going to perform better than orange? We've created a hypothesis now. Just to make this is one variation. So even though I did change the header text to be completely back, this entire thing is considered one variation. Okay, so it's as a unit we made a change. So that's OK. Now, next step is gathering all your necessary data. We need to understand some simple things. So what kind of data are we looking for? The first thing is going to be the click-through rate. How much are people clicking the button currently? This is going to be our baseline conversion number. And this is going to be everything that our experiment is going to be testing to see if we can improve this conversion number. So we need to understand what is currently our reality. Next, you're going to need to measure weekly traffic. How many people are seeing this button even, and how many people are clicking on it? You need to know how long this experiment is going to need to run. And from that, you're going to need to know how many people are seeing this. Now, what else are we going to potentially look at? A/B experiments are great because they allow you to measure a lot of secondary metrics. Anything else on that page, we can measure and know the impact of our experiment on those secondary metrics. So let's go a little bit in specifics for this experiment. So our key metric is, again, that click-through conversion rate. So how many people are looking at the business page and then clicking on Start Order. Our secondary metric is going to be conversion. We are looking at total orders placed. So that means you click Start Order, then you added an item to your cart, and then you actually checked out. So we're caring about making sure that the reason people are clicking on that button isn't just because we made it bright red and now everyone just clicks on it to see what it is. It's actually because we're getting more people to notice it that have the intent to actually order food. Makes sense, right? We want to make sure that if you're getting into the funnel, you're actually going to complete through the funnel. So we want to see that increase. Alternatively, we could also measure things like ads on that page, or other potentially important secondary metrics for us are things like reviews on that page. If we had made it bright red and flashing, you could imagine everything else would have been negatively impacted. So an A/B experiment would allow us to measure those secondary metrics really well. But we think this is going to be green is OK. It's not going to take an effect on everything. So we're going to measure those secondary metrics, but that's not the most important thing. We want to care about this order completion. OK, so now we need to do a little bit of math. Pretty explained. We're going to use a minimum detectable effect of 5%. That means that we're going to want to see a relative increase in our conversion by 5% to say that this experiment is statistically significant. We're going to use a statistical power of 95%, which is on the high end. Industry standard is 80%, but we wanted to run this experiment to understand really well that we were making a change to be impactful, right? This is investigating how A/B experiments, so we wanted to have a very high statistical power, and we're going to use a standard significance level of 5%. OK. Running a little bit of math, we're going to use some sample size calculations, and we're going to get that we're going to need about 300,000 users per variation. OK? So now, if we make the assumption that we get 1 million users a week, which Yelp gets a lot more than that, but we're going to make that, then you can consider that this experiment would be run within 1 week, right? Because you're going to need half to be in a control group and half to be in your variation. And I'm going to talk about that a little bit more later. Well, OK, great. Now we need to implement this. All right, we know how to code. Let's work on this. So as I said, we're going to need to keep a control group. Control group is going to be really important for a couple of reasons. One, we want to measure our baseline conversion, not on our past data, but on our current data. And this keeps our control. This way we know what our users are doing constantly and make sure that there's no no change. With food orders, there's a lot of seasonality. A/B experimenting will let us know that our change is the reason that we saw an increase or a decrease, right? So we want to know that it's the change itself that's making that impact and not some other underlying cause. And by keeping a control group, we can tell what the current conversion rate is for this day or week. So it's important to keep a control group always when you run an A/B experiment, right? A, B. So makes sense. So we're going to do 50% for each. You could do more or less. We just did this because it makes sense. We're going to split it evenly so that we can make sure that we're investigating it correctly. OK, next. A little bit of code, right? You're actually going to need to run this. At Yelp, there are a lot of other experiments are running from search, from actually other teams that are constantly working. And one of the things is that there's basically a giant dictionary for every user at the current request into what experiment are you being bucketed. And we don't want to constantly have to query this giant dictionary. So instead, we're going to use Quark so that way in our code, we're only caring about our experiment. The other benefit is that then you get actual defaults that you can say within this. It makes your testing better. It makes it a lot easier and makes it compact. OK? Makes sense. All right, test. Testing is very important. Of course, it's important. But it's really important when you're doing an A/B experiment. You want to make sure there's no bugs in your code. You want to make sure that there's nothing going wrong. And not just in your code, but also visualization, right? When you're actually making this change to the button, you want to make sure it's proper, right? Changing the CSS to make it green is simple, but you want to make sure that you're able to see both the orange and the green now, right? If you said that by using quarks, right, you could say that you are now in the default variation. You should make sure that your output is getting orange. If you're in the enabled group, you should make sure that you're seeing green. So you want to make sure you're testing this. You want to make sure that the entire workflow is working correctly and that the color is outputted correctly. OK. Now we get to roll this out. So for us, we roll it out in a couple of steps. First, we do internal rollout, make sure there are no bugs. We make sure that there's nothing wrong. Then we'll go to a very small percentage of traffic for a short period of time to see the enabled. This just gets us a little bit more validation that we are still seeing no bugs in our experiment. If we do see something that's wrong, we can always turn the experiment off and then not let anybody see the enabled variation, and then fix our code, and then roll it back. And then we roll straight to our predetermined traffic percentage of 50%. OK, so now let's say we do this. We have now run our experiment, and now we can wait and get our results. So we come back, and it's been a week, and we see something. We've got a 5.26% relative increase, which is fantastic. This actually means that we had an experiment be successful, right? We were looking for a 5% increase. So anything above that means that we had a statistically significant effect. So green is better than orange. Fantastic. So you can now go and tell your PM this, and he is super excited. All right, now he can go and keep going on all the experiments. He has plenty of ideas for what else to run, and now we have a new issue. We have an abundance of experiments. So you can imagine, right? Instead of now one thing that they want to change, there's 100 things that they can change. And each one of those, they can come up with 5 different variations for them, right? So we actually have a lot of experiments now that our PMs want to run. Well, let's think about this. We know how to do that. Let's go through it. First thing first, we're going to need to have our hypothesis. What are we testing in all these experiments? So first, our PM came up with a good idea. They want to take the button color, and they want to look at it again. And they want to make sure that it wasn't just that we changed the color that was better. We want to make sure that we got the best color that we could have. So we're going to run this with multiple colors now. And each one is going to have its own amount. And we're going to see which color is best. Was it green that was actually better? Or was it just that we got rid of orange? Could it be red or blue that actually makes us the big impact? OK, makes sense. And another thing they want to run. So here's the business page again. Now, in the English language, which most of our users are, the way that you see and the way that you read things is in an F shape. So like this, right? You read from left to right and top down. Now, if you notice, our widget is outside of the F. So this means that not a lot of users are probably paying attention to it just because of its location. So let's take this and change the layout and move it to the left. So we're going to move everything to the left that was on the right so that now it sits firmly inside that F shape. OK, that makes sense. We're going to use just simple psychology to make it so that people are seeing our button far more by the location. OK, that makes sense. So now we need to run our next step. We got to gather the necessary data. We actually have a big advantage here since we're testing on the exact same component as we were before. We actually have the same data to use from last time. We know the exact same baseline conversion that we just ran on, and we know what our weekly traffic rate is. But we're going to do a little bit more. That layout change, for example, it touches a lot of things on that page. So we want to make sure that we have a lot of secondary metrics that we are going to measure. We're going to actually check everything on that page, see the conversion rates on other components, as well as ads are on that page. Revenue still is generated mostly through ads, so we want to make sure that we're not negatively impacting our ads conversion. OK, so there's one more thing that needs to be changed. Since we now have multiple variations for our color experiment, we're actually going to need to do a little bit of refactoring and recalculating our number of our sample size. And this is just a simple correction. And all you need to do is update your alpha value for the number of variations that you're running. OK, now we'll implement this. So same thing as before. We're going to create a couple more if statements. We're going to have a number more bucketing. We have 5 colors now. We have 2 layouts. OK. And now let's run this. But we've got an issue. You can actually now be left in green. Not only can you be left in green, you actually have the full set of things that can happen. We have 5 colors and we have 2 layouts. And all of these can be combined. And now we're going to have an issue. Before we were just measuring 2 things. Now we thought we were going to measure 5 and 2. We actually now have 10. So having to measure 10 different variations is going to make it so that our experiment is going to have to run far longer, right? And you can imagine if we were to run a 3rd experiment or a 4th experiment on this underlying component, it's going to multiply the number of variations that we're running. So this is an issue, because now it's going to take us a lot longer to run our, right? Because each variation needed that amount that we calculated from the sample size. So having more variations is going to make it so it take a lot longer. So we can go back to our PM and tell them, hey, that's not going to work. We can run everything sequentially, but now we're back to only running 1 experiment at a time. And that seems like not OK, right? We should be able to do more than 1 experiment at a time, right? This seems like something we can solve. So we came up with something called swim lanes. And this is the way that we got about this. So let me rewind and explain a little bit about what that means. This is currently what we have, right? You have an experiment. It's off or on, right? Orange or green. We have our second experiment, left and right. This is the reality right now, right? They're overlapping because they're running simultaneously. And the way that that would be spread is, not significant. So we could measure all of that, but we don't want to do that because it gets a lot more complicated, right? We have a lot more variations that we would need to measure, and this doesn't scale very well. So we're going to think about this like a pool. In a pool, every swimmer has their own lane. And every time they swim, they're not running into the other people because they stay in their own lane, right? So similarly, we're going to do that for our experiment. Each one is going to get assigned a lane, and the users in that will be then divided as they were before. So this lets us predefine our users into experiments and assign them a lane. This allows for us to control which experiment you're in and which you're not, which means that we're actually running experiments exclusively for one another. And this has a couple of advantages. So we're going to see it like this. An experiment, let's say, gets the top lane. Top 2 lanes for our experiment for colors, and bottom 2 for layout. So if you are assigned to lane 1, you're going to be in orange. If you're assigned to lane 2, you're going to be green. You're not going to see left and right. You're only going to see the color change because you're staying in that swim lane. So we're going to pre-partition our experiments so that way you're not seeing them simultaneously. So that's the way that we're going to get by this. So now instead of multiplying the number of variations, we're only adding them because each one has been pre-assigned a swim lane. Okay? So this means, right, that the length of time for running our experiments gets cut way down, right? Because instead of having 5 times 2, it's now 5 plus 2. So now it's only 7. And you think how this scales when you start to run more and more experiments, right? It's not multiplicative, it's additive. So that makes it a lot better, okay? There's another advantage. We can now actually stagger when we're starting experiments, right? Because if we tried to run them and have 10 variation, you'd think we need to start this from the beginning, because otherwise you're going to have some very messy data to deal with, of when one experiment started, when another one started, how did they affect each other, how did they not affect each other. Instead, we're very much isolated. Each experiment is its own group, and we have each one to start and end at different times. So a different developer could work on a different experiment. A different person can work on it. You can stagger the times. You can analyze them on their own. You never have to worry about all of the times that you did it. When did this one start? When did the next one start? How did they mesh up? How did the data get affected? So it makes it a lot easier in that way. But we have some trade-offs, right? So now getting testing is a little harder. So instead of having only an experiment be enabled and disabled, it's now enabled, disabled, or not existent, right? So we want to make sure that our default case for if you're not in the experiment is what we expect it to be, right? So let's look a little bit about the code I had before. Before, I was checking if you were in our status quo or our control group and setting it to orange. Well, you can imagine now, if your experiment is none, you're seeing green, and that's not what you wanted, right? We wanted our default case that if you're not in the experiment to stay to orange, okay? So we want to make sure that we're always actually assessing it by which cohort that you are enabled in. So you can imagine, right, you'll have if it's green, if it's blue, if it's red, right, always going down. So assigning specifically to what we want and having the same default to the end, which is what we expect it to be, okay? So now we roll this out. And the first thing we want to make sure is that we actually got the right way that we actually did our swim lanes correctly. So it's for us, when we implemented this, we had to actually measure our swim lanes behaving correctly and testing that as well. Otherwise, we would have actually still seen all of that cross variation. So we measure correctly that we actually split out our traffic correctly. But then at that point, it's now simple. We're back to just running A/B experiments and measuring them. So now we get to analyze our result. We wait a little bit, and we got back. And it's great. Green definitely is the winner. It's a far greater success. And you can imagine that we actually saw a big improvement from this, from having 2 experiments seeing this increase. In terms of a minor thing, if you look at the error bars, there's just a slight overlap with that dark orange color. And you can imagine yourself, do you run another experiment now of comparing the green to that dark orange? Well, at this point, you can always keep experiments, but we actually made a product decision of this is good enough. We've seen green do very well for 2 experiments in a row, and we can decide that we're going to continue with just having green for now, and then maybe in the future we can come back to this decision. But now we have the data to tell us that green is statistically significantly better than orange. And we can now consider running these other colors and how their impact. And if we ever wanted to revisit this decision, we could see why we made it, as well as what could be our effect for running a follow-up experiment. In terms of the layout, it's just as expected. Moving things to the left saw a huge increase. Everything that got moved to the left side, so not only our button, but everything else here, got at least a 10% increase in click-through rate. And some even saw as much as 20 and 25%. So no surprise there. You know, seeing things move to the left is the way that people in the English language just read. So it just became far more prominent in their visualization. But there was something that happened negatively. Everything that got moved to the right now saw a decrease. And primarily one of the things that are there is our ads. Our ads got shifted to the right and saw a drop. Now, at this point, you can consider, have we seen enough revenue increase from our continuing getting orders compared to our ads? And we didn't. So at this point, we were like, OK, this experiment will not be rolled out in its current format. We're going to go back to the drawing board, redo this layout, and then rerun this as a follow-up experiment. And it was thanks to doing this as an A/B experiment that we could understand very well the impact of this change. Before, we wouldn't have been able to tell us that it was specifically the left-hand change which caused this drop in our ads. So swim lanes made it so that we could tell exclusively that it was our layout which caused this impact. So with that, I hope you now have a far better understanding of how to run an A/B experiment. And even though it is a little harder than just changing the CSS of button, it's actually really doable. And you can manage that complexity for when you try to run multiple experiments. For us, we use swim lanes as the way that we can run experiments exclusively, so that way we can test the same underlying component at the same time. Now, that doesn't mean there aren't other solutions, but in terms of this is the best way that we've gone with in terms of getting a lot of these experiments. So we, again, ran just 3 experiments for investigating, and we saw 15% increase in our revenue. From then, we've actually kept on running a lot more experiments, and we've seen a really big impact in our understanding of our features, as well as our understanding of our users by running these experiments. So with that, I'd like to say thank you.
We have plenty of time for questions.
Yes?
Talk a little bit about your infrastructure. Like, did you use an off-the-shelf tool? Maybe I missed.
No. So, yeah. So in terms of the way we run this, everything's actually custom. The majority of this implementation is all via request. So everything is done by bucketing on the request. So that way you're assigned an experiment variation when you start a request. There are off-the-shelf solutions for this. We are still in the works of actually open sourcing our solution, but that's farther down the line at the moment. But the main point is that you can actually do a lot of this by just going through the steps of the bucketing yourself, and you can consider that you make sure that you measure this appropriately. Yes?
Yeah, I have 2 questions. First one is, so you said that the increase is 5%. How do you define how much increase you have to get so that the A/B test is significant?
Yeah, so let me answer that first question, and then I'll get to your second one, okay? So the question was, in terms of how do I know that how do I define what my intended increase is, and then how do I measure from there what it is? So all of that is actually done, right, when we do our calculations. So at this point, right, at this point is where we actually decided that we're trying to reach for 5%. This just as easily could have been a minimum detectable effect of 3, 2, or 10. Right? So at that point, we're actually making the measurement for how many users we're going to need to see. So if we ran an experiment with a 5% minimum detectable effect, and we saw a 10% increase, then we are definitely successful. If you see a 5% as your bar for success, and you see that you only get 3%, then according to your definition, your experiment was inconclusive.
How do you define this minimum detectable effect?
A little bit of practice, and actually we do multiple calculations. So every time you change, so if you have a lower number, the length of time of your experiment is going to be higher. If you make your number too low, everything is going to need to run forever, so maybe it's not worth it for you to make that change. So 5% is a pretty good, you actually saw success. If you go below 2, you probably shouldn't be running that experiment because it's too low of an impact.
This must have to do with the variance,
Right, but this is the frequentist approach. If you get to 5%, and you have enough users, then you definitely were statistically significant.
Your variance is like 10%, and then 5% is below your rate.
Right. There are different approaches for how you can deal with that.
Sorry, I still have a second
Right.
question. Regarding the experiment design, so you use like, I didn't understand this swimming pool examples, but in my, just like a primary idea that if you have like 2 variables and each variable have, for example, 4 levels and 2 levels, then you can just design your experiment like 8, you divide your data into 8 parts and then you can get all the combinations.
Right. So there's a couple. So running things like that, you actually can, but then you can't see the exclusive changes of one experiment's effect. So for example, in our case, if we had run it like that, we wouldn't have been able to say so strongly that just by moving things to the left, you saw a negative impact in ads.
But you already designed your data, so you can, if you want to see left or right, then your data still have 2 parts, right? Even you divide it into
Right, but what if left in green has a different effect than left in blue, and right in green has?
add all of them together.
It doesn't work exactly. You have to do a lot more math, actually. The other thing is you have each one of your variations is going to need this many users. So you're going to need to run your experiment longer. So instead of having 8, we ran down to 7, right? Which, granted, 8 to 7 you don't see a lot. But when you run 4, 5 experiments at the same time, it starts to quickly scale up to being you now have 20. Or you have a far greater number of variations that you need to do calculations for. So it is doable, but it's a very different approach, and that's not the one that we wanted to go down. Yes.
Thanks a lot for sharing. We run a lot of A/B tests as well. I'm wondering if you can elaborate on the team structure and the ownership. So who is actually owning the experiment? Do you have data science team who analyze it? Do you have engineering? Do you have a product manager? So can you just elaborate how those all pieces work together?
Yeah, so in terms of our team, Yelp has a data science group. We have an entire PM organization as well as like PMs assigned to teams of engineers. For us, the data scientist is really a little bit more of consulting in terms of this. We have this approach for running an experiment. During this process of investigation, we were working very closely with the data science team to make sure that everything that we were doing as we were learning was appropriate. But following running these like 3 experiments, we now only check with them, a lot less frequently because we know what our approach is. Unless we're doing something a lot more crazy, we could just follow this same routine and just go through these steps and crank out experiments. And then individual engineers are the ones who are owning the individual experiments. Because they're running exclusively, you can actually control it so that way each engineer is just responsible for their experiments. They make sure to coordinate like when experiments are running and how much they need for traffic, but otherwise it's very much individual ownership. And then the product side of it is very much like helping decide before the experiment is launched what are intended. That's where we like, okay, what do we expect as our effective increase from this? Is this a good experiment? After I run some simple calculations, will this be a good enough experiment for us to run right now, or is this not going to be effective compared to some other feature that we need to work on?
So engineer would also analyze results and share the results with everyone.
Yes. Yes.
Right, so this is not directly related to stats, but I was wondering, how do you combine these sort of incremental changes from A/B testing and the overarching design principles so people can feel on the page?
Yeah, so in terms of so the question is how do you make the decision of what the incremental changes are for your A/B experiments, and how does that go with the long-term vision of the product? Is that correct? So the long-term vision of the product is really what drives these A/B experiments. For us, we care about increasing the amount of orders. So for us, this is the main product. How do we keep improving this? How do we keep improving the user experience and the bottom line at the end, because this affects directly revenue. So that user experience is what we're caring about improving. So an A/B experiment of how do we start with getting more users into the funnel is where you can consider that. What the incremental changes are, we want to run a lot of A/B experiments, actually. We actually want to go at a very quick rate of launching and starting and completing experiments, so that way we have a better understanding of how a new feature might have an impact as a simple prototype of a simple button instead of the full-fledged feature. So for us, we're able to use A/B experimenting to really ramp up our speed of actual development, because we can do a short amount of time in an A/B experiment, or we can do a longer amount of time in a simple feature A/B experiment. So that's how we do this in terms of making sure that it fits within our long-term vision, and then go through very incremental changes to get there. Yes?
Quick follow-up question on how you select which users go in which pocket. Is that you tag them in the user database, or is it on the request via site?
So for these sorts of experiments, it's all on the request side. So we do basically a random. So when you generate a new request, you'll get a cookie that has, and then from there, you're assigned into a variation. After a certain period of time, that cookie gets refreshed, so then you get reassigned.
If somebody uses 2 browsers, potentially they could be in 2 different groups, but that's statistically.
Yes.
Right.
Yes.
So, have you guys thought of automating the experiment and the results? So based on the result, the website adapts to the output and maybe serves more content which is doing better. Machine learning on top.
Right. So the question is, have we done any consideration into automation of running all these experiments and then launching new ones and changing on top of that? Yes. It's actually a very big project. You can imagine any sort of automation on a result of an experiment is actually very complicated. You need to understand the impact of what that experiment is and understand it. In the case of, like, for example, that layout change, that experiment was a success. It saw a 9.3% increase, which is more than 5%. You can imagine that could keep getting better, but it has a negative impact on ads, which for us is still more important. So it gets complicated in terms of figuring out a larger set of metrics that you will then need to say how an experiment overall is doing, and then understand, will that need to be, is that good enough to roll out completely, or does it actually require more changes before it's gone into production? And the reality is, a lot of time that's a lot easier to just do by person. You know, there's actually a lot of conversations about how the product will change and what experiments you want to keep running afterwards, rather than automating the full thing. But we are working on automating, you know, a lot of this process in terms of the calculation and in terms of just those simple launches. So turn off and turn it on. Yes?
What's the benefit of the approach you took with swim lanes compared to something like bandit algorithms or Bayesian testing? Why have you gone for this approach?
Right, so the question is what is the advantages of the swim lanes compared to an alternative such as a bandit approach or a more Bayesian approach? So as I was saying, the swim lanes allow for us to exclusively see an experiment at a time. We wouldn't have been able to say that the left side caused the negative impact to ads if we did a bandit approach. So being able to make really strong assessments and strong statements about your experiments is some of the advantages of an A/B experiment, right? You'll know your secondary metric impact from your experiment. And running them all at once, you know, the calculations become more difficult. So running them individually, in a way, allows for it to be a lot easier for you to understand. It allows for developers to keep working them at the same time and not worry about their impact on a separate experiment. In terms of the Bayesian approach, that has more to do with the analysis and calculations rather than actually your approach to launching experiments. And we are actually using a more Bayesian approach now. It's been a year since we started this. But it was just, at the time, it was a lot easier for us to start like this. Yes?
It was a really great talk. Just curious, like from your experience, why you define your treatment group by customer rather than by visit?
So the question is, why do we define our experiment variation assignment by visitor rather than customer? And a lot of that is actually based that how do you define a single customer is actually a very difficult question, especially for something like Yelp, where you have users who are on mobile, on desktop, on potentially a lot of different devices at the same time. And instead of trying to always say that you are one user and you're going to be in all these experiments, it's a lot easier just to be this visit, this visit, this visit. That's why we actually do sessions. So it's not like when you visit, you will be bucketed and you'll stay on that until for a very long period of time. So it's not just on the like, every time I refresh the page, I'm going to be in a new bucketing. So that's how we approach it. So it's not just like exactly per visit, but it's a long-term per visit sort of approach. Yes?
So if, for example, you knew that by the first time, if you were selling cars, by the first time somebody started researching cars on your site, till the time someone actually buys, it's 5 days. The period, right? Then I guess you would run an experiment of at least 2-3 weeks, and I guess you would discard the data from the first 5 days because actually you would have incomplete sessions up to that point.
Right.
Your transactions are much shorter, I guess.
Right. So the question is in terms of the transaction length compared to the length of the experiment. If you have a very long transaction length from when you're considering starting a transaction to when you actually want to complete, then your experiment will need to either run longer to capture more time, or you'll need to discard some of the initial data because the users would have been affected by your experiment from the beginning. Because for us, it's a lot of food orders. As you can imagine, the time that you order for food is for tonight, for the next hour. It's 6 o'clock right now, I'm hungry. I want to order some food. It's not it's a very quick decision-making process. So it's not a transaction that you need to worry about for the next week, right? So it makes it so that we can constantly keep experimenting on our users, which is a really big advantage. So it is important to always take into account the way that your users are using your product and the way that you need to approach it for them. Anything else? Yes?
Example you showed, the test power of 95%. So when you're showing these results to people in like marketing or managers, what level of understanding do they have of the risks involved in that?
Right. So for us, it's a lot less with marketing. It's a lot more of understanding how the product. So as I said, that 95% is a far higher significance threshold than normal A/B. Like the industry standard is only 80%. So we were keeping it at that higher threshold because we were doing initial investigation and wanted to make sure that we have a very good understanding so that we could say with very strong confidence this experiment is working. When we really working with our product people and our data scientists, they've started to develop this understanding of what does your confidence mean? How strong is this experiment? But a lot of times that question comes up when an experiment is borderline successful or has negative impact while being successful, for example. And at that point, it really isn't about the significance, it's more about the impact. So a lot of times it's more about understanding your impact on that bottom line. When we saw the left-hand change, we saw a 10% increase in our click-through rate, but we saw a drop down in our ads revenue. So that outweighed the current decision, right? So then they understood, okay, we need to go back. We need to consider how would we better do a layout for this page, so that way we can go through this process again and get an impact that's advantageous to everybody. Make sense?
Just last question.
Two questions if we're time, but the first is about prioritization and the second about the negative effects that A/B tests can have. So in terms of prioritization, you said there's a trade-off between features or tests. So I'm interested in how you prioritize what tests to do first, I guess, and whether that's kind of a back of the envelope, this is what we expect to happen, and this is how we choose what to do first.
Yeah, so the question is about how do we prioritize the new experiments and how do we kind of go about the trade-offs between a new experiment and change and a new feature. And the reality is that we can actually even do new feature releases as an A/B experiment, which allows for us to actually get a better understanding of how those will affect. And usually from full features, you actually see a much bigger than 5% increase. So it makes it very quick to run an experiment that just like a quick validation. What else is there anything that got negatively impacted? Which makes it so that way we can just roll out features in a very controlled way. In terms of just general improvements, so styling sort of changes, we do the first two steps of the A/B experiments to really get us the understanding of how long will it take, and then we can go back to product and tell them, this is what we expect if we assume a 5% increase and assume going through what's our current traffic analysis, this is how long an experiment's gonna run, 2 weeks, 4 weeks. Is it gonna run, it's gonna take us 6 months, then the product can go back and be, okay, well, if it's gonna take us 6 months right now, but what if instead we built this first feature, then would it go through, and then it drops down 2 months, they can make the better prioritization of build this first, build this next, test this out afterwards. So really going through the process, even if it's the first couple of steps, it's very short. It gets you a good understanding of what you're currently looking at. It gets you a good understanding of what the question that you want to ask. And it's really helpful to go back to product with that understanding. We've actually gone through and made an entire document of write up what your experiment is planned to be. And just going through those steps led for a lot of engineers to make a good understanding of what their potential trade-offs are, and having to go through and know, oh, actually, I'm not even measuring my current button right now. I can't tell you what our conversion rate is. So sometimes you just need to go through that first two steps so that way you can understand, and then you can approach it and then prioritize appropriately.
Okay, let's thank again Noor for this great talk and for coming all the way from California.
Thank you.